Welcome to Dr. Sherry's Astronomy channel. The topic of this episode is the true nature of an interstellar object finally revealed. The dramatic transformation of 3I Alice captured by NASA's latest satellite. On July 1, 2025, a new visitor appeared in our solar system. Named 3I Alice, this comet is the third confirmed interstellar object to arrive from outside our solar system. This comet was discovered by ATLAS, Asteroid Terrestrial Impact Last Alert System, using a 50-centimeter telescope installed in Chile, South America. The Atlas in the comet's name is derived from the team that discovered it. The I in 3I stands for interstellar, indicating it came from outside the solar system. And the 3 signifies that it is the third such interstellar object ever confirmed. The primary reason 3I Alice is classified as an interstellar object lies in its orbit. The observed path traces a hyperbolic trajectory, rather than the elliptical orbit of objects trapped by the Sun's gravity. This calculated hyperbolic orbit indicates that once it passes through the solar system, it will never return. At the time of discovery, this comet was traveling at the tremendous speed of approximately 221,000 kilometers per hour. It is believed that this immense velocity is due to the momentum from when it was ejected from its birth system, as well as the kinetic energy accumulated while drifting through the galaxy for billions of years. Furthermore, upon analyzing this distinctive orbit, astronomers believe this comet is far older than our solar system and originated from the Milky Way's thick disk. The thick disk of the Milky Way is a distinct region where stars older than those in the thin disk where our solar system resides, are concentrated. This diagram shows the Milky Way from above, while the Sun orbits as shown by the yellow dotted line. The orbit of 3I Alice, shown by the red dotted line, extends into the thick disk. Viewed from the side, it looks like this. While the Sun remains in an orbit close to the galactic plane, the thin disk, the orbit of 3I Alice oscillates significantly above and below the galactic plane. This unique trajectory is the basis for the theory that it came from the thick disk, home to ancient stars. If this hypothesis is correct, 3I Alice could have formed over 7 billion years ago, long before our solar system was born about 4.5 billion years ago. In other words, this comet can be considered a living fossil of the universe that has traveled for a mind-boggling amount of time. Therefore, studying this comet is expected to provide clues about the appearance of the past universe and the state of the galaxy before the solar system was born. To investigate this precious comet in detail, various telescopes are conducting emergency observations. One of them is NASA's new satellite, SPHEREX. SPHEREX is a highly unique space telescope launched in March 2025. This satellite possesses characteristics exactly opposite to those of the James Webb Space Telescope, which zooms in to observe specific celestial bodies with high precision. Its role is to thoroughly survey every direction of the cosmos and create a precise three-dimensional map of the entire sky every 6 months. In short, it is tasked with a mission akin to a national census, revealing the actual state of the vast society that is the universe. The exterior of SPHEREX is surrounded by large shields to block heat from the Sun and Earth, giving it a shape like a giant megaphone floating in space. Moreover, the aperture of the telescope mounted at its center is only 20 centimeters. This is the same size as commercially available astronomical telescopes, but this small size is its greatest weapon. While giant telescopes have very narrow fields of view, SPHEREX was intentionally designed to be compact, allowing it to capture a very wide area at once and efficiently scan the entire universe. The most significant feature of this mission lies in its technology to finely analyze light by splitting it into 102 colors. While standard digital cameras capture light in 3 colors, red, green, and blue, SPHEREX decomposes light with overwhelming precision, more than 30 times that amount. This means it acquires images and spectra simultaneously. Through this specialized observation, it can accurately determine the distances and compositions of over 450 million galaxies and more than 100 million stars in the Milky Way. In December 2025, just 6 months after starting operations, Spherix completed its first all-sky map. This animation is a panoramic video that adds depth to a flat map. Created by scanning in all directions while orbiting Earth, essentially painting the inside of a sphere, this map brings the universe's three-dimensional structure into relief. What makes this 3D map possible are the layers of 102 colors. The numbers displayed as the screen changes in the video represent the wavelength of the infrared light being observed, in other words, the color of the light. At short wavelengths, stars shine clearly as points, but as the wavelength gets longer, clouds of gas and dust that were previously invisible begin to emerge. This is because celestial bodies and substances have the property of emitting light strongly only in specific colors. By scanning the entire sky in 102 distinct colors, Spherix renders hidden matter that only reveals itself at specific wavelengths, drawing it out as if slicing through it one layer at a time. Spherix, with these characteristics, is also incredibly effective for observing extended objects like 3I Atlas. Comets, in particular, show dramatic changes as their surfaces warm up while approaching the Sun. Solar heat turns surface ice into gas, causing gas and dust to erupt with force. As a result, a massive cloud-like structure called a coma is created around the nucleus. This transformation progresses rapidly before and after perihelion passage, the point of closest approach to the Sun, and the comet's brightness and shape can change significantly in a short period. Occasionally, outbursts occur where eruptions suddenly intensify, or the nucleus itself may fracture due to heat and gravitational influence. In fact, another comet discovered around the same time as 3I Atlas, C 2025 K1, was observed to brighten suddenly and split into multiple fragments just after passing perihelion. When the nucleus splits, a cross-section is exposed that has preserved the comet's condition from the time of its formation, unaffected by sunlight or cosmic rays. Therefore, the comet's original components, which had been sealed inside the outer shell altered by years of drifting, become directly observable. Incidentally, C 2025 K1 is not an interstellar comet but a long-period comet from the Oort cloud at the edge of the solar system. It is thought to be an icy body from 4.6 billion years ago when the solar system was born, preserved in its original state. Moreover, because it has never approached the Sun before, it is considered a primitive object retaining information from the birth of the solar system, and it attracted great attention from astronomers worldwide from the moment of its discovery. Therefore, the splitting of the comet provides a rare opportunity to capture substances from the formation of the solar system billions of years ago that were sleeping inside the nucleus. Thus, comets can change in activity intensity and visible components before and after approaching the Sun. Consequently, to ascertain what components the interstellar comet 3I Atlas possesses, it is crucial to capture how it changed before and after perihelion. And a powerful tool for capturing such changes is Spherix, which can observe a wide field of view in 102 colors simultaneously. Spherix succeeded in observing this interstellar comet in detail on 2 occasions, before its perihelion passage in August 2025 and after the passage in December 2025. Imprinted in that data was a dramatic transformation, as if the comet, warmed by the Sun's heat, had awakened from a deep sleep. The first observation was conducted from August 1st to the 15th, 2025. At this time, 3I Atlas was about 3.2 astronomical units, 3.2 times the distance between Earth and the Sun, away from the Sun, a location still too distant for water ice to evaporate rapidly. When we look at the image captured by Spherix, it looks like this. The component that stood out during this period was carbon dioxide. Its release rate was at a tremendous pace of approximately 120 kilograms per second, creating a massive gas coma extending over a radius of 3 arc minutes. On the other hand, the release of water molecules was modest, and furthermore, carbon monoxide was found to be less than 10% of the carbon dioxide. It is thought that the carbon dioxide, actively changing from ice to gas, removed latent heat, thereby keeping the nucleus's surface temperature low and suppressing the eruption of water and other volatile substances. In short, at this stage, 3ILS was in a low temperature state before its activity fully intensified. Then, on October 30, 2025, 3I Atlas reached its perihelion passage, approaching to a distance of about 1.35 astronomical units, approximately 200 million km, from the Sun. At this time, the intense solar energy received by the comet is believed to have reached not only the surface but also deep inside the nucleus through heat conduction. So, how did this comet change after passing perihelion? The dramatic scene answering that question was captured in detail during Spherix's second observation on December 8, 2025. About a month and a half had passed since the comet crossed perihelion, and although it had receded to a distance of about 2.2 astronomical units from the Sun, the comet's activity far exceeded the scale confirmed in August. Looking at the actually observed image and spectrum, it appears like this. The most notable change appeared in the amount of water released. In August, water emission was not very noticeable, but in December, it was being released at approximately 420 kilograms per second, a 40-fold increase. Furthermore, the release of carbon monoxide jumped to approximately 550 kilograms per second, about 80 times that of August, surpassing carbon dioxide to become the main component of the material released by the comet. Also, Spherix observations newly confirmed light derived from organic matter, such as CN, cyanogen, and aliphatic hydrocarbons with C, H, bonds, which were not detected in August. Furthermore, looking at the images captured by Spherix, we can see that the spread of gas differs for each component. Carbon dioxide and carbon monoxide, erupting directly from the nucleus, formed a symmetrical distribution centered on the nucleus. On the other hand, the distribution of dust, cyanogen, water, and organic matter had an asymmetrical shape, protruding toward the Sun. This difference in distribution suggests that the water and organic matter were not released directly as gas from the nucleus. Rather, it indicates a secondary release where ice-containing dust particles ejected from the nucleus were heated by exposure to sunlight while drifting in space, turning into gas. Thus, the detailed data captured by Spherix tells the story of 3I Atlas entering a different level of activity after its closest approach to the Sun. So, what were the factors that caused such a dramatic change bordering on the perihelion passage? Primarily, two possibilities are being considered. One is that the heat from the close approach to the Sun was conducted to the interior of the comet. In other words, the theory is that the heat breached the hard outer layer, about 10 meters thick and altered by cosmic ray irradiation, reaching the primitive ice layer deep within that retains the form it had at the time of formation. The other possibility is that the main component, water ice, began to turn into gas in earnest. This is a physical process where carbon monoxide and organic matter trapped within the ice crystals were released all at once as the ice transformed into gas. In this way, the continuous all-sky scanning by NASA's new satellite, Spherix, succeeded in capturing, as quantitative data, the process by which a celestial body traveling through interstellar space exposes its internal materials due to solar heat and changes its chemical characteristics. It will be exciting to see how the activity of 3ILS changes in the future and what further components will come to light. Thank you for watching, and I'll see you in the next video. If you enjoyed this video, Please don't forget to give it a thumbs up. Hit the subscribe button and the notification bell icon, so you'll be notified when new videos are released.